In today's fast-paced digital landscape, delivering applications with minimum latency and high resiliency is paramount. I'll walk you through a cutting-edge solution that integrates Fi distributed cloud with Arista switches to achieve an optimized multi-site deployment. This architecture not only prioritizes local data center performance, but also leverages AWS as an overflow site. All also leverages AWS as an overflow site, which is shown in the right, ensuring seamless application delivery even under high load conditions. On the left side, you will see a private data center where the application is hosted locally. And on the right side, you will have a AWS based deployment. At the heart of this architecture is Fi distributed cloud customer edge, which serves as a control plane, and the Arista switch that manages BGP peering and ECMP routing. Together, this component provide a resilient, scalable, and highly available solution for modern applications. So we have deployed a cluster of customer edge nodes to ensure resiliency. These nodes are interconnected from the primary point of entry into the private data center. They manage all configuration through a single plane of glass interface on the F5 distributed cloud console. The Arista switch connects with the C cluster via L3 interfaces. BGP peering is established between the Arista switch and the C nodes, enabling dynamic routing. ECMP routing is used to distribute traffic evenly, enhancing the overall resiliency of the network. There is a load balancer which is configured on the C cluster with the IP 10.10.124.122. This IP is propagated to the Arista switch, which directs local traffic to the application server in the data center. By keeping the traffic local, users benefits from the lowest possible latency. Now, let's talk about the AWS overflow site. This is, you can say, as a secondary deployment. The same application is also deployed in the AWS site, which is that SCS-AWS3. This deployment is configured with lower load balancer priority compared to the local data center. The pool management is different. Like if you look at for the AWS deployment, the priority is lower. The load balancer ensures that both sites can be accessed seamlessly. When the local data center experiences congestion, the load balancer intelligently routes traffic to the AWS site. Thus, overall overflow mechanism guarantees that users also have access to the application even during the peak load times. Now let's look at the demo. So we have two sites here. We have the AWS site as well as the Arista data center site, which we have discussed before. So here let's look at the Arista data center site. We have 3 node cluster here, and these nodes are connected to the regional edge accordingly for resiliency. You can see like for each node you have the outside and inside interface. Now let's look at the other side, which is the AWS site. AWS site, it's deployed in US West 2A zone, availability zone, and again it has an inside outside interface uh, on that, right? Now let's look at the virtual or the load balancer here for the Juicebox app. So here you can see it's a HTTP load balancer. I have 2 origin pools, which is one app is in the AWS site and the same app is in the private data center as well. And you can see the priorities accordingly, right? So currently the priority is it's a lower priority to AWS, so it's all traffic is going to through the AWS site app. So let's look at the app response here. Say I can go to the juicebox.app site and everything is working fine. Let me enable the script so that we have traffic going on to that site. Now, if you go back to the Cloud Console, you can see that I'm changing the priority for the Juicebox app to 1 and saving it. So now you can see that the traffic which was on AWS site eventually will move to the data center site, right, which is Arista data center site. You can see that that's happening here. So now let's look at the BGP peers information. So we'll go to the site or networking on the site and go to the BGP. And this is my BGP configuration. So I go here. Actually, you can see that all the 3 node clusters are peer with the Arista switch. 222 is actually the Arista switch. So you can see that all like each node is basically registered to the Arista switch to build that resiliency. Now let's look at the BGP peers here as well. So if I go and do this, actually you can see that for each node, the Arista switch is peer, right? For node 456, it is paired with that, and that is the peer ACN number, which is 65001. Likewise, right? Like it's there for all the nodes. Now let's look at the routes. So if you see on the routes, you have different routes coming in into the cluster. 10.10.124 is actually a subnet which is connected for the Juicebox app, um, which we should see in the switch, right? Like if you go to the switch now, Arista switch, you can see that peer information for each of the cluster nodes. And if I do PGP route, I can see the route for the load balancer as well, which is 124.122. So that information is propagated to the switch as well. So you have that connectivity built in, right? So that's pretty much it. Thanks for watching